Good day, students. Welcome to part 2 of the implicit differentiation practice. We're just going to sharpen our skills on the art of implicit differentiation. So let's go ahead and get started with question number 1. So we're going to find dy dx. So we have the equation. Let's change this. We have the equation cosine xy. Cosine xy plus x to the fourth equals y to the fourth. Okay, so if we want to differentiate this implicitly, we're going to use a chain rule and the product rule to differentiate this. So we're going to use the chain rule and the product rule to differentiate this. So that you know the derivative of cosine is negative sine. So if I differentiate the outer function here, I'll have negative sine xy. Now I'm going to apply the product rule and differentiating the inner function. Remember the product rule, if you have product of two functions uv, the derivative of that is basically u v prime plus v u prime. Okay, so in this case my x is going to be my u and my y is going to be my v. Alright, so the derivative of xy is going to be times u, which is just x, and then v prime is dy dx, and then plus v, which is y, and the derivative of x is simply dx dx. We're multiplying this derivative right here, the outer, by this inner derivative due to the chain rule, plus. Now if you differentiate x to the fourth using the power rule, you have 4x to the third dx dx. And then on the right side, you apply the power rule to differentiate y to the fourth. You have 4y to the third dy dx. Okay? Alright, let's simplify this a little bit more. We can distribute negative sine xy to this term. So this part is going to become negative x sine xy dy dx, and plus y, because dx dx just reduces to 1, and if you distribute that to that, actually the sign changes. So it basically becomes negative y sine xy, dx dx reduces to 1, plus 4x to the third. The dx dx just divides out to 1, and then equals, on the right side it just stays the same, 4y to the third dy dx. Okay, so what I'm going to do is I'm going to move this dy dx over to the left side. So we're going to have negative y sine xy plus 4x to the third equals 4y to the third, and if I bring this over here, and I can also factor out dy dx, so if I bring this over here, it becomes plus x sine xy. Since this and this both have dy dx, I can factor out the dy dx, so I have dy dx. Okay, and then to finally get dy dx by itself, I divide both sides by 4y to the third plus x sine xy, and I'll have the final answer will be dy dx equals negative y sine xy plus 4x to the third divided by this term right here. As a result of dividing both sides, we have 4y to the third plus x sine xy. Okay, so there goes your final answer. So this is the same as option letter B. Alright, let's go ahead and take a look at question number 2. We're supposed to differentiate this implicitly, so we have 3y plus 8xy minus 2 equals 0. So you see you have to use the product rule here again. So if I differentiate this one, I'll have 3 dy dx. And then for this one, I'll factor out the 8. And I'm going to use the uv prime plus vu prime again. Okay, so this is u and this is v. So remember uv prime is equal to uv prime plus bu prime. So if I differentiate, so I just bring out the u is going to be x, v prime is derivative of y with respect to x, which is dy dx, plus v, which is y, and then dy dx. Derivative of x dx is simply going to be derivative of x with respect to x is dx. And then the derivative of -2, since -2 is a constant, the derivative is 0. So minus 0 equals 0. So if we reduce that, we're going to have 3 dy dx plus 8x dy dx plus y, because dx reduces to 1 equals 0. Okay? And what I'm going to do now, I'm going to factor out dy dx on this from this term right here. But before we do that, I can go ahead and subtract y from both sides. Oh, actually, I was supposed to distribute the 8 to this y right here, so I have 8y. Okay, so this 8 needs to be distributed to both terms. Alright, so now I can subtract the 8y from both sides, so subtract 8y. Remember, I want to get dy dx by itself, so subtract 8y. And then we're going to have, and then let's factor out dy dx from these two first terms here. So we have dy dx times 3 plus 8x equals negative 8y. And then now I can divide both sides by 3 plus 8x. Divide this by 3 plus 8x. And this by 3 plus 8x. And then our final answer, dy dx, is going to be negative 8y divided by, let me see how they structured it, 3 plus 8x, 3 plus 8x. Okay? Alright, so let's see which one matches with our answer. The answer is option A, negative 8y over 3 plus 8x. Alright, let's move on to question number 3. So we have x to the 6th equals cotangent y. We know that the derivative, d dx of cotangent y, is simply negative cosecant square y, right? So let's apply that to this problem. So if I differentiate dy dx, let's forget that. If I differentiate this side using the power rule, I'll have 6x to the 7, having 6x to the 5th power using the power rule, dx because we're differentiating with respect to x, equals, now the derivative of cotangent using this idea will be negative cosecant square y dy dx. Okay? So let's reduce this, and we're going to get dy dx by itself. So this reduces to 1. So I have 6x to the 5th equals negative cosecant square y dy dx. If I divide both sides by negative cosecant square y and use the reflexive property of equality, I have dy dx equals 6x to the 5th divided by negative cosecant square y. Alright, so our answer is going to be option A. Okay? Alright, let's move on to question number 4. We're going to differentiate 2y squared minus 3x squared minus 11 equals 0 implicitly. So if I differentiate this, I'll have 4y dy dx using the power rule and 2y squared. And then this becomes negative 6x dx. And then the derivative of 11 is just 0 equals 0. So the goal here is to isolate dy dx. So let's simplify this a little bit first. So we have 4y dy dx minus 6x equals 0. So if I add 6x to both sides, I'll have 4y dy dx equals 6x. And then divide both sides by 4y. And then my final answer, dy dx, is going to be dividing the top and the bottom by 2, 3x over 2y, and there you have it. Okay? Option letter A for number 4. Alright, let's move on to question number 5. We have 5y minus 5x squared equals x minus 5. Differentiating implicitly, this one is going to be 5 dy dx using the constant rule, and then this one we're going to use the power rule. Here we're going to have 10x dx dx because we differentiate with respect to x, and this will simply be dx dx. You can think of there could be a 1 here, and it's just like 1 dx dx. So, and then if you differentiate using the constant rule, this is simply 0. Okay, so let's simplify this a little bit. We're going to have 5 dy dx minus 10x because dx dx reduces to 1, and then this also reduces to 1. Now to isolate dy dx, what we'll do is we'll add 10x to both sides, and then divide by 5. So we're going to have 5 dy dx equals 1 plus 10x. And when you divide by 5, you have dy dx equals 1 plus 10x over 5. And there goes your final answer. The correct answer is option C. Alright. Moving along to question number 6. We have 9x plus 8y equals 6. Now, to differentiate this, or implicitly, the derivative of the first term, we're going to have 9 dx dx. And then the second term is going to be 8 dy dx. We're differentiating with respect to x. And then using the constant rule for this equals 0. Okay? Now the goal is to isolate dy dx, and that will be that. So, reduce this first. We have 9 plus 8 dy dx equals 0. So to get dy dx by itself, I'll subtract 9 from both sides. So I'll have 8 dy dx equals negative 9. Divide both sides by 8, and then we'll have dy dx equals negative 9 over 8. And there goes your final answer. And that is option letter B. Okay? Alright. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel for future updates. You can share this video with your friends via Facebook or Twitter. More videos can be found on mathwithsir.com. Thanks again, and have a wonderful day.